This is section 4.6, and we're going to talk about rational functions. And they're related to polynomials because they're made up of polynomials. So this little definition here says a function f represented by p of x over q of x, where p of x and q of x are polynomials, and that you don't have a zero down here, is a rational function. So part of the requirement is that you have to have a polynomial on top and a polynomial on the bottom. To find the domain of a rational function, the restriction issue here is that the denominator of a fraction can't be zero. So you set q of x, the bottom, equal to 0, and you solve. So I took this x minus 5 and set it equal to 0, and that gets x equals 5. This is the restriction. That's not the domain, that's the restriction. So the domain, the formal way to write it is you have a brace, you have the variable x, this line which we read such that, and then x not equal to 5, and close it with a brace. So let's read that one more time. The domain is all x's such that x is not equal to 5. That just means it can be everything else in the world. Okay? All right. The restriction is also called a vertical asymptote. So if we look at this graph here, this function is 1 over x minus 2. And if we just look at that, we know from what we just did, if we take x minus 2 and set it equal to 0, we get x equals 2 is the restriction. X equals 2 is the vertical asymptote. That means this graph goes here and says, whoops, can't be at 2, I'll go down. Goes here, can't be at 2, got to go up. So that's what that looks like. Now there are horizontal asymptotes as well. And so when you look at this one, this is a y equals 1 horizontal asymptote. And so this function can go along and it can go, but it doesn't cross y equals 1. And same thing over here. Now, the difference in the two, the vertical asymptote is a hard no. Nothing can cross it of the function. The horizontal asymptotes occasionally that may cross, it's not real common, but it can. So it's not an absolute given that it can't. Now here is something about finding vertical and horizontal asymptotes, and all of this information is in the yellow packet handout. And so there's a whole part on this, but to find the vertical asymptote, we just did that. We set it equal to the denominator equal to 0 and solved, and that gave you the vertical one. The horizontal one, you're talking about the degree of the top and the degree of the bottom. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is a horizontal asymptote. If the degree of the numerator equals the degree of the denominator, then y equals a over b, where a is the leading coefficient of the top and b is the leading coefficient of the numerator, of the denominator. That's when n equals m. This is when n is less than m. If the degree of the numerator is greater than the degree of the denominator, then there are no horizontal asymptotes. So there's three possibilities. N is less than m, n is equal to m, or n is greater than m. All right, let's look at one. If you were asked to graph, and in my face-to-face, we have to do that, and even in online there may be a show work problem where you do have to do the actual graphing. So we've got r of x equals 3x over x plus 4. So we want to find the asymptotes. For the vertical, we take the denominator, set it equal to 0, and we get x is negative 4. For the horizontal, let's look at the degrees. The degree here is 1. The degree here is 1. So n equals m. That means we have to look at the leading coefficients. There's 3 and there's a 1. So y equals 3 over 1, or just y equals 3. So we found all the asymptotes. Then we go to a grid and we put dotted lines for this equation and this one. x equals -4, dotted line going through x at -4, y equals 3, dotted line going through 3 on the y-axis. Then you go to your calculator, go to y1, and put 3x divided by x plus 4. Be sure you put that in parentheses. And you'll get these two pieces. But you have a road map of where to put them, because you can't cross those lines. So that's how we get that function, just a sketch of it. So that's how we'll do that one. Let's look at another one. All right, let's look at this one. This one is 3x times x minus 1 over 2x squared minus 5x minus 3. So we can take the denominator, set it equal to 0, factor that, and we get 2x plus 1 and x minus 3. This gives us 1x equals -1/2 and an x equals 3. So we have two vertical asymptotes. When we look at the degree, this is actually 3x squared, and this is 2x squared. So our degrees are the same, n equals m. And so it's y equals leading coefficient over leading coefficient. So we have y equals 3/2. So we go to our graph over here, and at the y, we can draw a dotted line about there. It's like 1.5, and put y equals 3/2. We've got x equals 3. We've got x equals -1/2. You can put it in the calculator. You could go ahead and multiply this out, or you could do double parentheses, but the whole top needs to be in a set, and the whole bottom needs to be in a set. And then when you graph it, you'll get these pieces, and you'll know right where to put them, because we've already put the restrictions. So that will be that. Now, this one, let's look. We have x squared minus 5x plus 8 over x plus 4. The vertical asymptote is x equals -4. The degrees, degree of the top is 2, degree of the bottom is 1, so n is greater than m, and you have no horizontal asymptote. If you don't have a horizontal one, you may have a slant or oblique one. And you have that if the degrees are different by exactly 1, which is what we have here. If you have a slant one, we want to go ahead and do the division. And we can do it with synthetic. So we have 1 minus 5 and 8. We write that down. Down here, we'll take down the 1. 1 times -4 is -4. Add those, we get a -9. We don't have to worry about the next column. We just need this. And it's y equals x minus 9. And so that is our slant asymptote. And I think that I have it graphed here. Yes. Okay, so I just showed you. I went to the calculator and put in the original. And I also put in the x minus 9. And you may have to change your window to see it. But here's our function. And here's our function, and what it's doing, it's following that slant line, just like that, and just like that there. So that's how you can have a slant asymptote. So that gives us our information about rational functions and the domain and the asymptotes. So let's go look at our problems. All right, number 1, determine whether this is a rational function and state its domain. Is it? Well, you look at the top, it is polynomial. The bottom is polynomial. So yes, it is a rational function. For the domain, remember that we take the denominator, set it equal to 0, and we solve that. So 8x equals 5, x equals 5 over 8. That's our restriction. It's the only thing that x cannot be, so we're going to choose C, all x's such that x not equal to, and we'll put 5 over 8 in there. Number 2, is this a rational function? State its domain. And that's kind of confusing because everybody gets used to looking for fractions. But you could write this thing over 1. We could think of it as x squared minus x minus 10 over 1. And 1 can be considered polynomial. It's a constant function, so it is a rational function. But it's defined for every x because the number 1 down there, we don't have a variable to worry about or anything else, so this is defined for all x values. Is this a rational function? Yes, it is. And this x squared plus 1, if we take that, it doesn't matter what x is, you're going to, if you add 1 to it, you're going to have a positive number. You won't go to 0. So it doesn't matter because it's a plus. So we just know that it's a rational function and that, okay, so the domain is all real numbers, and we have that there. Number 4, is this a rational function? Yes, it is. What's the domain? If you take the bottom and set it equal to 0, then x equals -2. There's no other restriction. So we go to C. The domain is all x's so that x is not equal to -2. Number 5, we're going to identify some things in this graph. Identify any horizontal or vertical asymptotes and state the domain. So when we're looking up here, that horizontal asymptote, is at y equals 2, and you write it as an equation, so don't just put the number 2, put y equals 2. It has a vertical asymptote, that's at x equals 1. The domain has to do with that vertical asymptote. So it's x such that x not equal to 1. All right, same thing with number 6. Identify. And so it looks like we have a horizontal asymptote at, now here they've got the y equals outside, so you'll just put the number 2 there. It does look like this is going to infinity and negative infinity. The domain is the set of all real numbers. Number 7. So it has one horizontal asymptote, and that is at, and it looks like the scale is a little different here. So these are going by 2s because there's a 10. So looks like at y equals 4 is our horizontal asymptote. It has 2 vertical ones, and that looks to be, and you'll see it better on your calculator, but it's in between. So I think that's x equals -3 and x equals 3. The domain is all x's such that x is not equal to -3 or 3. All right, number 8. Same thing, we can begin to kind of see our vertical asymptote is x equals -8. The horizontal, the degree of the top is 1, the degree of the bottom is 1. So, and the coefficients here are 1. So y equals 1 is our horizontal asymptote. Number 9. 3 over x squared plus 3. Well, the degree of the numerator, it's an understood x to the 0. Degree of denominator is 2, and so that means y equals 0 is our horizontal one, and it doesn't have a vertical one. Remember, x can be anything because you're going to add 3 to it. You're going to square it, and you're going to get positive values. So let's go on down to 10. Okay, the vertical asymptote, take the denominator, set it equal to 0, and you've got x is 4/6, it's -4 over 6, and reduce that to -2/3. The horizontal, okay, we've got a degree 1 and a degree 1, so it's -3 over 6, that's y equals -1/2. Okay. Number 11, let's see if I can move this over a little bit. Okay. x to the fourth plus 1 over x squared plus 4x minus 12. If we take the denominator, set it equal to 0, you can factor it to x plus 6, x minus 2. That gives you x is negative 6, x is 2. Those are your vertical ones. The degree of the denominator is less than the degree of the numerator. So when you have that, you have no horizontal asymptote. All right? Number 12 has something a little bit different we need to take note of. And number 12, we note that it's already in factored form, and we note that two factors are right here, and they cancel out. So you don't count them in the vertical asymptote. So we're going to cancel those out, and then we only have the x minus 4. So x equals 4 is the vertical asymptote. The degrees are the same. So y equals 1 on the horizontal, because that's leading coefficient both places. 13, determine the graph without using a calculator. Well, we know that there's a vertical asymptote at x equals 5. Here it's x equals a negative number. Here it's at x equals 0, could be 1. Looks like right here, because these are going by 2's, there's a vertical asymptote at 5. So there's our graph. Let a be a positive constant. Determine the graph without using a calculator. Well, we are just seeing that we need a vertical asymptote at x equals 4. So right there, I see that. We don't see that anywhere else. So that should be our A. 15, find the domain, the vertical and horizontal asymptotes, and the graph. So vertical asymptote, we should be able at this point to look at that and say that's 1. X not equal to 1 is the domain. And the vertical asymptote is x equals 1. Degrees are the same, coefficients are 1 and 1, so y equals 1 is the coefficient. You could check, you could do this, you could try to do this without the calculator, or you could throw it in the calculator and see what your graph looks like. But here we've got a vertical asymptote at 1 and a horizontal asymptote at 1. So I think that that's the one we need. Number 16, vertical asymptote is x equals negative 4. We don't have a horizontal because the degree here is bigger than the degree here. We have a slant because it's 2 and 1. The difference is just 1 in the degrees. So we'll write negative 4 here, and we'll have 1, 0, negative 8. We didn't have an x term. We'll bring down the 1, multiply, you get negative 4, and we get to stop there. And so the equation of the slant asymptote is y equals x minus 4. Let's try 17. Vertical asymptote, x equals 1. Higher degree there than here, so we don't have a horizontal. We have a slant. We've got 1, 2, 2. So we've got x squared plus 2x plus 2 over x minus 1. Vertical asymptote is x equals 1. We do not have a horizontal because 2 is bigger than 1 on the degrees. So let's look for our slant. They're different by 1, so that works. So we'll put our vertical asymptote here, and we'll have 1, 2, 2, bring down a 1. 1 times 1 is 1. Add, you've got 3. So y equals x plus 3 is the slant asymptote. And so you want to graph that, and I would put it in the calculator. And let me do that for us. Just hold one sec. Okay, I have gotten that in our calculator. And I used the alpha y equals to get the fraction icon, so I could just put that on top and that on bottom. And then I put our slant asymptote in y2. When I hit graph, I don't know what the window was, and so to match it, let's go to the window, and these all look at like 20s. So negative 20, 20, and a scale of I don't know what the scale is. Let's see. Could be by fours. Let's look. I think that looks right. 4, 8, 12, 6. Yes, they're by 4. So we'll do 4 there. And then we have negative 20 for the y min and 20 there. And we're still at 4. Okay, let's see what that looks like. Okay, well, we should be able to, let's see, look, and we can tell that there it is right there. Dotted dashed line, and that's my red line, which is the x plus 3, and then our pieces. So I think if you'll do that, if you'll put it in like this, and then you'll make sure your window matches the numbers that are on the window for the question, then you should be able to see what you're doing. All right, number 18, last one. Give the equations of any vertical or slant. Well, the vertical is x equals 5, and we'll do the division. 5, and then we have 4 and 3. Bring down the 4. 4 times 5 is 20. That's a 23. We didn't need anything over here anyway, so we've got 4x plus 23. So we've done a good bit of work on rational and vertical and horizontal asymptotes and domains. So I think that should be good for 4.6.